All right, in the last video we talked about angles in standard position. In this video we're going to discuss a little bit more about that and talk about a family of coterminal angles. So let's take a look and see what I'm talking about here. We've got coterminal angles are angles that are in standard position. By the way, if you haven't seen that video, go back and watch the video on standard position so that way you know what I'm talking about. And these standard position angles have the same terminal side. So for instance, if we were to draw out 70 degrees, we know that 70 degrees is about 20 short of 90, so it's right here. That is 70 degrees. I want another angle that lands right there. So when I spin this thing around, here's my terminal side that I spin up to 70 degrees. If I continue and go another 360 degrees all the way around the circle, I land right back on top of that same side. And that's what I'm looking at when I'm talking about coterminal angles. So that's 70 degrees right there in red. If I took this light blue right here and said, what if we went 70 degrees and then a full circle around from the 70? So that would be like adding 360 to that 70, making it 430 degrees. So if you were to graph 430 degrees, it looks like this. And if you graph 70 degrees, it looks like this right here. Notice they have the same terminal side. The only difference is this one got spun around an extra circle. We could have also taken it the other way and said, let's go up to 70 and then subtract a circle from it. So let's do that in a different color here. We'll use a dark blue this time. If I were to say 70 minus 360, then I get negative 290. And so negative 290, remember we start with negative angles. We start right here and we're going to go negative 180, negative 270, and then 20 degrees past it that way. This is negative 290 degrees. They all have that same position for their terminal side. That is what coterminal angles are. They land on that same side there. Doesn't matter how many times you spin around in the circle or how many circles you have there. And so that's what we're doing in this lesson. We can have positive coterminal angles. We can have negative coterminal angles. Notice this was a negative coterminal angle to 70. And then what did we have? 430 degrees was a positive coterminal angle to 70 degrees. Let's try another one here. Let's try 100 degrees. Now I know 100 is about 10 degrees past that quadrant angle of 90. So it's going to be really close to the 90 right there. That is 100 degrees. If I wanted a positive coterminal angle to it, then I'm going to go to that 100 and then I'm going to go 360 more degrees. So if I'm drawing this out in blue here, I'm going to go to that 100 and then I'm going to go 360 degrees past it. So it's going to be 100 plus 360, giving me 460 degrees. But there's more than one positive coterminal angle here. Let me draw it out in red. If I went to that 100 degree mark, I could go one circle around and then another circle around. So I could add two circles to that. So that would be 360 plus 100 plus another 360, giving me 820 degrees. 360 plus 360 plus 100. So 820 is coterminal with it. In fact, I could add another circle to that, another 360, and get, well, let's see what we get. I've got to do a little math here, don't I? Add 360 to it, I get 1180. That's another coterminal angle. So I'm just keep adding and adding and adding circles. I can add an infinite amount of circles, so there are an infinite amount of coterminal angles in the positive direction. Let's take that same angle of 100 degrees, draw it out, and come up with some negative coterminal angles. So here's 100 degrees again. So I'm going to go out to that 100 mark, but this time I'm going to go the opposite way. I'm going to say, let's subtract a circle from it. So if I went up to 100 and then subtracted a circle, I'd be going around like this right here. Now this angle, remember, it's got to start at the initial side. So this angle actually starts, I'll draw it in green, it starts right here and it traces around to right here. We don't count this first 100 degrees to it. So basically what I'm saying is 100 degrees minus a circle gives me negative 260 degrees. So I'm starting here and I'm going this green, what's highlighted in green, is negative 260 degrees. That is a negative angle that has the same terminal side as 100 degrees. I can subtract another 360 from that. So basically I'm saying subtract 2 circles now from a 100. And I'm going to get, what do we get here? This becomes 2, 1, 3, 620 degrees. That makes sense. 720, that's 2 circles, minus 100 from it. So negative 620 is 2 circles subtracted from that 100 degrees. If I subtracted another 360, I'd have a third negative coterminal angle, which would give me 980. And I keep going and going and going with this. So there are an infinite amount of negative coterminal angles I can come up with. So either way, we can come up with a bunch of positive coterminal angles. We can come up with a bunch of negative coterminal angles. But just saying subtracting a bunch of circles and adding a bunch of circles is not enough for mathematicians. We want to write this out in a pretty concise formula, don't we? So let's take a look and see what that looks like. Here we go. It says if theta is the angle, all right, then the family of coterminal angles is represented by this right here, theta plus 360k. All right, that's what you need to know as far as a formula goes. If you're a formula person, there's your formula right there. So what do these stand for? Well, obviously theta is your angle here, your beginning angle that you started with. 360, that sounds familiar. That is how many degrees you have in a circle. What do you think k stands for? K stands for the number of circles you got. You know, we've got a whole number of circles here. Or I guess you could say an integer, we could have negative amounts of circles. So in this example we just did, we said, okay, 100 degrees plus 1 circle. In that case, k is 1. So 100 degrees is your theta plus 1 circle. And then I said, wait a minute, we could add 2 circles to it. So if we added 2 circles to it, we take that 460 and add another 360. So in that case, we got 360 plus, or 360 times 2, that's 2 circles, plus 100, and that gave us 820. How do we get to 1180? We added 3 circles. 3 times 360 plus 100 gave us that 1180. This formula also works for negative values of k. So the first one we did, we said, let's subtract 1 circle. K was negative 1. Then we said, let's subtract another circle. You're subtracting a total of 2 circles. K equals 2. 2 times 360 is 720. And then subtracted from 100, we get negative 620 there. And then finally, we subtracted 3 circles. And you can keep going and going and going with this. In fact, you could make the argument that if k is 0, then 100 degrees is a coterminal angle with itself. So k can be any positive whole number. It can be negative numbers. It just can't be like fractions. You can't have k equal 1/2, because then that thing is only going to go halfway around the circle, and it won't be lining up with it to be a coterminal angle. Now, I put this here to remind me to discuss with you some radians as well. So 360 is the equivalent in degrees to how many degrees there are in a circle. Think about what that means in radian measure. In radians, we've got 2 pi radians. So if you're in my class and we haven't talked about radians yet, then I'm probably going to tell you or remind you like, hey, you don't have to worry about this till later. But maybe you're just watching this video as a review and we've already talked about radians, or maybe you're not even in my class and you're just watching this because you love math. We can do the same thing with radian measure. So 2 pi is a full circle, and so we can add a bunch of circles. If we're talking about radians, this angle right here is going to be in radians, and we'll see some examples of that. And we're going to add multiples of 2 pi, or we could subtract multiples of 2 pi, and that covers our bases there for both adding and subtracting them in radians or degrees. All right, let's look over 6 examples here. And so here they are. And what I'm going to do is this is how you'll see it on my quiz or my test. It says list 1 positive and 1 negative coterminal angle for each. So we're going to start with 30 degrees, and I'm going to draw 30 degrees. It looks like this right here. And if I want a coterminal angle with 30 degrees, we're in degrees, so I'm going to add multiples of circles. So I'm going to add 360 to that. So a positive coterminal angle for 30 is going to be 360 plus 30, which is 390. That's just adding 1 circle to that 30 degrees there. Now, if I subtract 360 from it, 30 minus 360 is negative 330. So that is my negative value for it there. And notice if we say go clockwise, negative 330 degrees, we're going to land 30 degrees short of a full circle, which is coterminal angle with positive 30 degrees, okay? Next one, negative 180. So negative 180 looks like this right here. If I add 360 to that, I get positive 180. And notice positive 180 looks like this right here. They are coterminal with one another. If I wanted a negative coterminal angle with it, well, it's already negative, but that's okay. I can say what's 180 minus 360, and that's going to give me 440 there. So negative 440. No, negative 540. I was like, that didn't look right. Negative 540. All right, 740 degrees. So this angle, notice what it looks like. If we start right here, we go, that's 360. Go around the circle again. That's 720. We're going to go 20 degrees past it. And there is our angle. That is 740 degrees. For one, you could take a note and say, hey, I just went 20 degrees past that initial side. So 20 degrees is actually coterminal with it. So we could write down 20 degrees for our coterminal angle. But if you're like, no, I want to stick with the formula, you could say 360, add it to the 740, gives me 1100. That's also coterminal with it. There's a lot of different right answers you could come up with here. Don't get too crazy. At least show me your work so I don't have to, I'd take either one of these obviously as a correct answer, but just try not to add, don't add like 1,000 circles or 1,002 circles and expect me to calculate it out. Show your work and keep it simple. Add or subtract a circle until you get to a positive or a negative. And that's bringing up my next point here. If I subtract 360 from this to get my negative coterminal angle, I'm going to get 380 degrees positive there. So I don't have a negative coterminal angle yet. So I'm going to subtract another circle from it, subtract another 360, and I get 20 degrees, which is still positive. In fact, that's that positive angle there I noticed earlier. So I'm going to subtract another 360. So I'm subtracting 3 circles so far. And when I subtract another 360, I'm going to get negative 340 degrees. And that's my winner there. I've got a negative coterminal angle. I'm going to go and write that down and submit that answer. All right, now we're switching to some radian measure here. So maybe you're familiar with this, maybe you're not. But let's go through it. Pi over 2 is right here. If you have no clue what I'm talking about, watch my videos on radian measures, all right? So that way we can, you understand this. And if you're in my class, then I probably will either let you slide on this for right now, or I've already taught you this. So here's pi over 2. I want to know a coterminal angle with that. So I'm going to say a coterminal angle is going to be pi over 2 plus 2 pi. So I'm going to do a little fractional work here. I'm going to change this 2 pi. Right now it's over 1. 2 pi is the same thing as 4 pi over 2. I'm multiplying the top and the bottom there by 2 so I can add them. They got to have the same denominator, right? And so this gives me 5 pi over 2. Pi over 2 plus a full circle, which is 4 pi over 2, gives me 5 pi over 2. There's my positive coterminal angle. Now to get to the negative one, I'm going to subtract a circle from it. So I'm going to subtract 2 pi, or I'll go ahead and write down as 4 pi over 2. And 1 minus 4 is negative 3. And this is still negative 3 pi's there over 2. There's my negative coterminal angle. All right, moving on to 7 pi. Now 7 pi, that's a fun one to draw out because you get to loop-de-loop a few times here. What color? Let's use green here. So I know 2 pi is a full circle. There's 2 pi. Let's zoom in so you can see it a little bit better. There's 2 pi. Focus. Go around again, and that's going to be another 2 pi, which is 4 pi total now. Go around again, and that is 6 pi. So every time we go around, it's multiples of 2 pi. So 1, 2, 3 times around, you're at 6 pi. One more pi. Remember, pi is only like half a circle here. So we stop right here. This is where 7 pi is. And so I want coterminal angles with that. Notice 7 pi is coterminal with pi. So I could just write out pi You can add 2 pi to it if you want to. That's a full circle. And I would take 9 pi. That's fine. And we're going to realize that any odd multiples of pi here are going to put me right there with 7 pi. So 7 pi, 5 pi, 3 pi, all those are coterminal. So I'm happy with any of those. To get a negative coterminal angle, we're going to subtract a bunch of circles from it. So I'm going to subtract 2 pi and get 5 pi. Subtract another 2, you get 3. Subtract another 2, you get 1. We're still all positive values, but if I subtract another 2 pi from 1 pi, I get negative pi. There's my negative coterminal angle. Maybe you notice like, hey, if I go this way, pi amount, you're at negative pi, and that works too, okay? So there we are for positive and negative coterminal angles with 7 pi. Let's now do negative pi over 4. That's what I'm going to do next. Negative pi over 4, we're going to add 2 pi to it. So negative pi over 4, by the way, if we graph it, is right here. So it's 1 pi over 4 short of 2 pi. If we go around the positive direction, we're 1 pi over 4 short of it. So if full time around the circle is 8 pi over 4, right? That's the same thing as 2 pi. So if I'm 1 pi over 4 short of it, I'm at 7 pi over 4. So you could write that down if you wanted to. If that's like too much for you right now, that's fine. Just add 2 pi to negative pi over 4. So 2 pi over 1 is the same thing as what over 4? Where I'm multiplying the bottom by 4 here, going to multiply the top by 4. That's how I come up with 8 pi over 4. After you do this enough, you start to see the denominator and say, if I want a full circle, I'm going to double the top, right? Or not double the top, but make the top twice. Make it so that it comes out to be 2 pi, and then you got a full circle. So over here, I'm just going to bring down that negative pi over 4. Now I can add these because they have the same denominator. Negative pi plus 8 pi is 7 pi. So there is my positive coterminal angle. To subtract it, I'm going to say, or to get the negative value, I'm going to say, here's negative pi over 4. I want a different negative angle. That's coterminal. I'm going to subtract a full circle from it, which is 8 pi over 4 again. We already did the work to come up with the common denominator there. And negative 1 minus 8 is going to give me negative 9, and this is negative 9 pi over 4. So I have, by the way, this should be 7 pi over 4 right here. I've got 7 pi over 4. I've got negative 9 pi over 4. That's my positive and my negative coterminal angle to negative pi over 4. Okay? Hopefully that clears some things up. If you're having any questions on coterminal angles, if you still have questions on them, let me know. I'll be happy to answer them. Thanks for watching, and I hope you're having a wonderful day.